We're going to be talking about things you're probably doing wrong. There it goes. So we did these things wrong, so you don't have to. We have a lot of catchy subjects today. We're going to talk about checklists. We're going to talk about zip ties. We'll be talking about what cuts what. A screwdriver is not, and it's a trick, it's not many things. I broke a bearing with the press. Glue. The solvent tastes bad. 3D printing is basically magic, and magic is hard, okay? Why are there so many kinds of plastic? And when you're a hammer, everything looks like a nail. First, I want to get some stuff out of the way. I am no expert, but goal of this presentation is to give a baseline of tricks and tips to the layperson to help them build robots. Do not take my words as the ultimate truth. The only thing I'm an expert in are 3D printing, Pokemon, and helicopters. Most of these tricks are to promote safety and function, brought about by years and years of scars from jagged zip ties. Let's talk about me real quick. As stated before, my name is Zach. I'm a mentor on Team 971. I take my job very seriously. That's a bad example. Hang on. Nope, another bad example. Sorry about that, guys. I take my job very seriously. A long time ago, I was a helicopter technician and crew chief. What that means is you have to ride in the helicopter after you fix it. It's very important that you fix it correctly because you're sitting in the giant aircraft that you just finished fixing. If you did something wrong, you're on the line. Safety is number one, but following directions is also number one. When it comes to doing things the right way, doing it the right way tends to be the safest way, and we want to make those both top priority. You need to learn from your mistakes in hopes of avoiding a future incident. If you did something wrong once, there was a problem, you need to write it down, you need to do an after-action review about what you can do better, and you need to incorporate that into the way that you work in the future. Slow is safe, slow is smooth, smooth is safe, be smooth. So here's a picture of me flying around in the jungles of Panama. If I forgot to install one of the bolts that holds the engine in, it'd be a very bad day. Here's a picture of me in the mountains of Afghanistan. Same thing. You need to make sure that you do all your jobs correctly. First one is actually a little bit dry, but it's something that we've developed over years and years of doing this. We're going to do checklists. If you look to the right, you can see the actual checklist for starting the engines on the helicopter. If it's good enough for a pilot, it's good enough for you. And all of aviation lives by these checklists. An example of an FRC checklist before a match would be, is your battery installed? Is your battery connected? Is your Robo-Rio connected? Is your Wi-Fi modem connected? Go over all of the little catch points that could lead you to lose a match. Make sure everything's good. There's no reason to skip ahead. Out of sequence means that you are skipping steps. When you skip steps, you're likely to not come back and revisit them. So if you find yourself doing stuff out of sequence, just develop a better sequence and adjust your checklist accordingly. And for those of you familiar with the internet, Leroy Jenkins rushed in and ruined a bunch of his friends' fun time in a video game. You do not want to rush when you're doing your checklist. If you only have a few minutes to get out there and start your match, you have a few minutes to run through your checklist and make sure that everything is connected. So now let's get into the fun stuff. Zip ties. Zip ties are a constant pain source for me, mostly because people are not doing them correctly and it can lead to little injuries on your hands. We're going to go over some pictures, by the way. I have plenty of pictures to share with you guys. The first thing about zip ties is one is never enough. There's no reason to go short on zip ties. Zip ties are cheap, zip ties are plentiful, and they're made to be consumable. Use as many zip ties as you need to get the job done. You want your zip ties to be flat, flush, and firm. You want them to be flat against all open surfaces. You want them to be flush, so they're providing good contact. You want them to be firm. That way, nothing that you're holding down with the zip tie can move around. We have a fun picture of a battery falling out of a robot because it wasn't zip tied incorrectly. I'll get there in a moment. Picture's on the next slide. Use zip ties to keep wires out of the mechanisms on your robots. You don't want your electrical connectors getting caught up in your transmission. So use as many zip ties as you need to get those wires out of the way. You need to keep them neat and tidy, or else you risk them getting ripped out during a match. Once you yank down on a zip tie, you'll have a long tail. We're going to talk about the right way to cut the tail of the zip tie off. And following in with that, we have why is everything so sharp? So first we have some pictures. On the left of my screen, you can see that a battery fell out of a robot during a climb back in 2017, I believe. That little Anderson connector there can be zip tied in place. So that even if your battery falls out, it won't cause you to lose the match. Moving over to the center of the screen, and I'll get my thing out of the way here. We have two different types of cutting mechanisms and the two different types of cuts they make. These are flush cutters. These are the preferred way to cut zip ties down. As you can see, there's not a lot hanging out. These are diagonal cutters. Diagonal cutters leave a little bit behind, and anyone that's worked on robots long enough knows what it feels like to reach down inside of your robot and have one of these sharp zip tie tails catch your hand. Moving on, I'll hide myself. While neither of these methods for chaining zip ties together are wrong, this one on the right is not applying very much force down in this area. So while neither one is wrong, the one on the left is much better for securing parts in place. You want to keep a nice even spacing with chain zip ties so you have good smooth force around your entire object. Next, we have a similar problem to the last one. If you apply the zip tie to the edge here, you get nice, flush, firm zip tie contact around the whole rectangular surface. But if you apply it to the middle, there's not very much force in this area I'm circling being applied to the object. So while this one will hold, it won't hold as well as this one. Also, it doesn't look as clean. Let me make my picture a little bit smaller, everyone. Sorry about that. So next slide is what cuts what. If you look at my fun little picture over here at the right, I got just a handful of cutters out of the cutter drawer. Starting on the right, we have scissors, we have a kitchen knife, we have metal shears or tin snips, we have an X-Acto blade, flush cutters, diagonal cutters, and these ones are actually for trimming dog toenails, but they work for other things. It's important to use the correct cutting tool for the correct cutting job. So first thing we're going to talk about is steel is good, carbide is gooder, but not always. These are some drill bits I used. These were carbide, or they weren't carbide, sorry, but these were just some generic steel drill bits, and I drilled into some masonry. And as you can see, it almost immediately broke. You need to be using the right tool for the right job, and that includes the right cutting mechanism for the right cutting job. Steel is good for cutting things that are softer than steel, but when you need to cut steel, as we often do on these robots, you may have to go to different types of cutting steels, high-speed steel, carbide. There are various ways to cut steel, and it's important that you choose the right one. Snip, we're going to talk about flush cutters versus diagonal cutters. Now, on the previous slide where I showed you the type of cut that the flush cutters make and the diagonal cutters, you would think, why would I ever use diagonal cutters? Diagonal cutters are actually stronger than flush cutters, just the way that the blade is formed. So if you need to cut something like a small nail, diagonal cutters can cut right through it versus flush cutters, which will bend and just not be very good afterwards. Tin snips, these metal shears, these can actually cut sheet metal. And these are scissors. They're like a really thin version of shears. Scissors are great for paper, cardboard, the material that you make your bumpers out of, but scissors aren't very good for cutting wood or sheet metal. And on the flip side of that, These tin snips are not very good at cutting paper, fabric, cardboard. So you want to use the right cutter for the right cutting job. Next, we're moving on to X-Acto. X-Acto knives are one of your best friends in the toolbox. They are fantastic, but they are only fantastic when they are sharp. These blades are cheap, these blades are consumable, and they are disposable. A dull X-Acto knife is a useless X-Acto knife. So it's very important to keep everything sharp. Why is everything so sharp? Part 2. Most injuries when using a blade or a cutting mechanism occur when the mechanism isn't sharp enough. So it's very important to not only use these tools correctly, but part of that is making sure that they're sharp the whole time. When a tool is no longer sharp, it is worn out past its service life, needs to be replaced. Fillet o fish. When you are filleting a fish, it's important that you cut the correct way. And I know you can't see my hands. When using a cutting tool, there is a correct way to cut, and it depends on the job you're doing. If you're using scissors to cut carbon fiber, cutting one direction along the fiber may not work at all. It'll dull your scissors and it'll just crinkle up the carbon fiber. And that works in most situations. You want to be safe and you want to cut away from yourself, obviously, when using the blade. But if you're not cutting in the correct orientation, your cutting tool is basically useless. Finally, we have what I call childproofing. You need to have your sharp tools separated from your regular tools. You don't want to have an X-Acto knife sitting in your screwdriver drawer. And also, when the X-Acto knife is past its service life, you need to make sure you dispose of it correctly. There's many ways to dispose of a sharp tool correctly, and one of them is not just throwing it in the trash. That's just leaving a sharp object in the trash for whoever takes the garbage bag out to find later. It's not a good day. There's plenty of safe ways. There's plenty of sharps containers. You'll see like a little yellow bottle that says sharps. You throw your blades in there. When you're done, you seal it, you throw it in the trash, and it's no longer a hazard. All right, moving on. Screwdrivers. Screwdrivers are the #1 misused tool in my experience. A screwdriver is not a chisel. Please don't use a screwdriver to chip away at things. A screwdriver is not a pry bar. Don't use it to spread components apart. There are proper tools for that. And the reason why is screwdrivers tend to be made to a different hardness than a chisel or a pry bar. You can risk snapping them. A screwdriver is not a different screwdriver. If you look at the picture on the right, you'll see all sorts of different screw type bits. I don't want to catch you using a flathead in a Torx. I don't want to use a Torx in an Allen key. Don't use a #1 Phillips for a #2 Phillips job, so on and so forth. Why is everything so sharp? Part 3. There's going to be a lot of these, guys. You need to keep your screwdriver bits in good working condition. In the same way that an X-Acto knife only works when it's sharp, a screwdriver bit only works when it is not damaged. If you bend your flathead screwdriver, it's not going to work anymore as a flathead. So it's very important to keep the flats flat. Keep your Phillips sharp, and when it's past its service life, if you continue to use it, you risk damaging all of the hardware that you're screwing in and out. So just use it correctly. I swear I hit a button. There we go. A screwdriver is not a paint scraper. So screwdrivers are hard, they're metal. And if you are scraping paint off of a metal surface with a metal object, you risk scraping that metal surface. You need to use the correct material paint scraper when doing those jobs. A screwdriver is not a drill. I can't tell you how many times I've seen someone just getting in there to get a thing out. A screwdriver is not a drill. No, seriously, a screwdriver is not a drill. I've caught students before using screwdriver bits because it was the right size and they couldn't find the correct drill bit. So please, please, please only use a screwdriver for its intended purpose. This is an actual picture of my actual girlfriend using scissors to assemble furniture where she was supposed to be using a screwdriver. Please, everyone, use the correct tool for the job. Next, we're going to talk about the correct way to use a press, in this case, a small arbor press. Bearings are expensive when you break 8 of them. I'm going to stop presenting for a moment so you can see my screen, or sorry, so you can see me, and I'm going to hold up. Here we go. See this little 3D printed bearing? When you're trying to press this 3D printed bearing out of its hole, there's a few correct ways to do so. If you press on the inner race or the balls, you risk damaging them. You want to push on the outer race only. But if you only push in one part of the outer race, you'll push sideways and you risk damaging the component for which you are trying to remove. So it's important to use something that correctly meshes with the bearing to push it out. Let's go back to my screen. It won't move. I tried everything. If you see the meme to the right, where you can tell that someone clearly just kept hitting the nails harder and harder until they went into place, that's not the right thing to do with the press. If it doesn't move fairly easily, you're probably doing something wrong. Take a step back, reassess what you're doing. You may even have to create a special tool to remove something. But do not double your force in order to get a better result. Doing so will break components. As stated at the top, I've broken several bearings before. And bearings get expensive when you start breaking them a whole bunch. Excuse me. Presses are an amplification of force. So if you start applying more force, you very quickly amp up the risk at causing damage to your components. All right, glue. I am unofficially the glue guru of 971, the glue-ru, if you will. There is a proper glue to use with almost every job. And unfortunately, since we're on lockdown, I couldn't get good pictures of the glue and the applicator. But not all glue just comes in a tube. Some glues require specific mixing and measuring and tools that do that for you. Those tools are expensive. It's very important that when using the right glue, you also have to use the correct equipment. That equipment is expensive, very much so. And it's vital to get it right. If your glue requires a 100-to-1 mix ratio and you're just kind of eyeballing it, you risk losing your glue. And when your glue doesn't cure correctly the first time, it's very rare that you can kind of recover from that, get it to work the next time. Come on. It's too hot in here is referring to hot glue. There are very few instant bond adhesives out there. Super glue and hot glue are the ones that come to mind. Super glue is great. Super glue sticks instantly, it sticks hard, gets into tiny little spaces, but super glue is really hard to remove. Hot glue sticks to lots of spaces as well, very easy to remove, very cheap. So if you do it wrong, you can kind of recover. You should be using hot glue for a lot of your prototyping. It'll save you some time, some effort. As I'd mentioned, proper mixing and curing are absolutely vital when you're using adhesives. Some of these adhesives have 48-hour, 7-day cure times. If you use them before they're at full cure, you risk ruining that bond. And once it's gone, it'll never repair itself. So make sure that you have the proper, it's too hot in here. Make sure you have the proper temperature when curing as well. A lot of these adhesives only cure above a certain temperature. So if you're working in your garage in Michigan in the middle of February, there's a chance that the 78-degree minimum cure temperature won't be reached. Read all the directions, follow all the directions, and hopefully you'll have a successful bond. Glue is icky. Glue sticks to you. Glue sometimes comes in several parts. And when I say it sticks to you, what I'm referring to is you need to be using the proper PPE for certain adhesives. If you're using epoxy, you need to be wearing gloves. If you're using hot glue, you need to be aware that it is hot. If you're using super glue, probably also want to be wearing gloves because super glue is activated by liquids. So as soon as it touches the oil on your skin, anyone who's used super glue has glued their fingers together. And the final step on glue is, once again, I didn't get a good picture. I apologize for this. Elbow grease is referring to surface preparation. Surface preparation is absolutely key. Back in 2018, with our carbon fiber arm, I glued it into the aluminum and I did it improperly, didn't do the surface preparation correctly. And it came undone a couple of times. We had to do a completely new bond during the competition at San Jose. So it's very important that when gluing components together, you do the right surface prep. For example, with epoxy, you'll need to scuff up the surfaces and degrease them. One of the things that we discovered, moving into our next subject, solvent tastes bad, was that we were using the wrong solvent. We were using isopropyl alcohol when we should have been using acetone. Acetone makes a much better surface prep bond in the case of aluminum and carbon fiber. So the first topic is my favorite solvent is illegal and I'm still upset about it. Many states actually lack the access to the proper solvent for the proper job. Some places you can get acetone, some places you can't. Some places you can get methyl ethyl ketone, another acetone type solvent. And you need to use the right one for the right job, but if you can't get it, it's usually there's an alternative available. Just have to do some research. Anyone who has used acetone while wearing rubber gloves knows solvents will do their job very well if you're not paying attention. The wrong solvent will melt through certain types of PPE. So it's important that you use the right PPE. Nitrile gloves are great when it comes to not letting solvents mix or melt through, but they're not a catch-all. You really need to be using the right component or the right PPE with the right solvent.
We have a question about glue.
Sure, send it.
You mentioned some expensive tools for mixing and applying glue. What specifically were you referring to?
Let me find it real quick. Back. Okay, here it is. Even with the spell check, I got it right the first time. So this is a special epoxy applicator for a special type of epoxy, in this case, 3M Scotch Weld. There are different, oh good, the dog's barking. There are different applicators for different types of epoxy. This is one that we use very often. The applicator itself is actually quite expensive. The tubes of epoxy are expensive, and these little, I may have to go grab my dog real quick, everyone. These small mixing nozzles that plug in are also expensive. The things that are important are to pair the correct mixing nozzle with the correct epoxy. Did that answer the question?
We can't see your screen. I'm not sure if you're sharing something.
Fantastic. I stopped sharing my screen. I apologize, everyone. Cool. Real quick to reiterate, this is the applicator I was referring to. It's for certain types of 3M Scotch Weld epoxies. These are the mixing tips for them. And I'll open up a page real quick to show you what that all looks like. You can see here on the right that you have the applicator, the epoxy, and the mixing tip. Apologize, everyone. I stopped sharing my screen. Did that answer the question?
Yes.
Yes, I think that answers the question. Then
All right.
another question, I think, from talking about solvent. When
Sure.
you mentioned rubber gloves, did you mean nitrile? And if you did, do you have any good alternatives?
So I meant that rubber is different than nitrile. You can buy rubber gloves There's various types of rubber. There's nitrile rubber, there's latex rubber. Some of them are even just plain rubber. And when shopping for gloves, they will often list the types of solvents that they are not susceptible to.
Yep, thank you for clarifying that.
So here you go. There's hospital grade gloves, which are sanitary but made of a different material than potentially these nitrile gloves, or the big rubber ones that you use in the sink. Things to look for are chemical resistant. It's not a catch-all, but that's key to making sure that they're not going to melt on you. Any more questions?
Not right now.
All right. Sorry about that. So, alcohol is useful as a solvent in many cases. I talked earlier about how hot glue is amazing. Well, rubbing alcohol basically dissolves hot glue. It's one of the best ways at removing it. But I had also mentioned how we'd used rubbing alcohol for surface prep on aluminum to carbon fiber bonding and how it was not the solution. You want to use the correct solution, solvent, for the correct situation. The caterpillar reaction or something like that. What I'm referring to is the capillary reaction. Solvents will wick between small gaps and up certain types of material. So you don't necessarily need to dunk an entire component in a solvent bath in order to remove the adhesive below. Sometimes just a small application of acetone between two bonded surfaces will be enough to wick up inside and remove the glue.
One more question.
Yes, please.
What's your stance on vinyl gloves?
Vinyl gloves. I really don't see a reason to not use nitrile. Nitrile is a little bit better at stopping like punctures and penetrations. So if you get nitrile gloves, they will work for like handling sharp stuff as well as handling things that are solvents.
Thank you.
Sure. So I mentioned alcohol is the solution. Well, with all solvents, solvents are chemicals. Chemicals are or can be pretty harmful to you. And this is a bottle of methanol that I purchased. And as you can see on the left side of the bottle, it's labeled as denatured alcohol or ethanol. The caption reads right around here that methanol is absorbed through the skin and is highly toxic. So, does this bottle contain 99.9% pure methanol or is it denatured alcohol? Denatured alcohol is not as harmful to the skin because it's only 5%. All the same, you need to be wearing PPE when using these solvents. Moving on. 3D printing is basically magic and magic is hard.
Before 3D printing, there was a question about should people remove the solvent before applying glue?
Solvents tend to evaporate if left alone, but you can also wipe them away to remove a standing puddle. You will need to remove the solvent before applying the glue because the job of the solvent is to thin the adhesive in many cases. If you don't wipe away the acetone, your glue will be too thin and it won't stick very well. Good to go?
Yep, we're good.
All right. 3D printing is basically magic and magic is hard. If you remember the beginning of my lecture, I mentioned one of the 3 things I'm an expert at is 3D printing. We're going to touch on some simple things here to stop from a lot of errors that I see people make constantly. Magic numbers are important. Let me make this real small. What magic numbers is referring to is printers have minimum resolutions at which they are capable of achieving. The resolutions are based on either the size of the nozzle of the 3D printer or the type of stepper motor and screw it is attached to it. In the case of the low market Creality 3D printers, that magic number is 0.04 millimeters. For Prusa printers, it's 0.05. And the way that that manifests itself is I created this part in SolidWorks. These are all different height steps, but then when I sent it over to my 3D printer, you can see it didn't quite translate very well. What were several steps of different widths and heights basically got rounded down. And the reason for that is the nozzle was 0.4 millimeters. So all these open gaps here, the gray is how big the part was supposed to be, are just not going to be printed correctly. You need to keep in mind when designing your components, things like how wide your nozzle is. If your nozzle is 0.4 millimeters and you try to design something that's 0.5 millimeters, you're going to have a gap. If your nozzle is 0.4 millimeters, you try to design something that's 1 millimeter, there'll be a gap on the inside. It's very important to remember those magic numbers when designing parts to be 3D printed. Next topic is freedom units and math. If you're like me, you work with engineers from all over the place. Some of them like to design things in inches. Almost every 3D printing program I've used only works in metric. So when someone wanted me to print something that was about 12 inches long and they send me a file output in inches and it ends up being like about a centimeter, make sure that you use the proper scaling factor. If you scale things incorrectly when importing from different types of units, you will have issues with overall accuracy. We're going to talk about SLA printers real quick because lasers are rad. SLA printers are a brand new type of printer that are available to the consumer. They print highly accurate parts. They're wonderful for many things, but they have a lot of downsides. One of the downsides, or sorry, we'll get to the downsides in just a moment. I have some pictures to demonstrate. Anyone who's been 3D printing for a while is familiar with Benchy. I'll show some pictures to demonstrate calibration. What the Benchy is used is for benchmarking your 3D printer. You may think that your 3D printer settings are correct, and then you print out something that's 30 millimeters and it ends up being 31 millimeters. And depending on how accurate you need your 3D printed parts to be, that could make or break your robot. 3D printing takes a long time, so it's important to get it right. Part 4 of why is everything so sharp. 3D printing often requires supports and support removal. And these supports are very sharp and they require you to use a tool to remove them. Flush cutters are great. I'll show you some examples of 3D printed supports in a moment. Come on. While on the subject of PPE and gloves and resin 3D printed resin is nasty, nasty stuff. It's getting much better, but you really need to wear all of your PPE when working with these resins, same way you would when working with glues and solvents. Resins also tend to be stinky. If you have your 3D printer in the same room as all the people doing CAD, they're going to notice it. So it's important to keep in mind that this resin is a chemical, and you don't want chemicals in the classroom at all the time. Here are a bunch of pictures about 3D printing because I had mentioned I love it. On the left, we have the Benchies that I talked about. You can see that this Benchy in this kind of copper color looks okay. This one in the clear resin looks much nicer. And this one I tried to print in Delrin, and it is a mess. The function of the Benchy is to benchmark your 3D printer settings. When your settings come out a mess, you make changes one by one accordingly. The Benchy has certain types of 3D printed features that are easy to narrow down what setting of yours is off, whether it's your cooling of overhangs, whether it's your retraction settings, whether it's how much warping your part does. Benchy is a great tool to get your 3D printer dialed in. If you look on the right side of the screen, you can see that once you get them dialed in, 3D printers can be highly accurate, either in FDM or in resin printing. But if you don't get them dialed in, this 10mm ID is not quite right. A lot of 3D printed materials shrink or expand when they're being printed. In this case, I was printing Delrin. Delrin shrinks when you print it. And it shrinks by a fairly constant amount. This was supposed to be 20mm, this was supposed to be 10mm. So if you wanted to print this part in Delrin, you can either make your holes bigger or you can scale your part up. On the right, you can see what good retraction settings look like and what bad retraction settings look like. On the left, you'll see me wearing a whole bunch of PPE in order to work with resin 3D printing. These are the supports that I'd mentioned. I have a picture of those being generated in just a moment. But this part is still wet. And one of the things that you have to do with resin 3D prints is you have to post-process them. Usually that involves a cutting fluid, a solvent, alcohol in the case of this. So you need to wear gloves when working with the resin because the resin can be toxic. You need to wear gloves because the solvent can be toxic. Here's an example of a down market resin 3D printer that this component was printed on. These are something like $270. So they're no longer $3,000 Formlabs printers. The accessibility of resin printing has come down a lot. Here's some more resin prints. You can see what the supports generated look like on the computer and in real life. You would be removing these supports with flush cutters. And when you remove them, they are sharp. It's essentially a tiny little plastic needle. You need to be careful. You need to wear gloves because you're working with resin. You need to wear gloves because you're working with sharp objects. So just keep that in mind when resin 3D printing. This picture is great and terrible. I wish I could get a better one, but on short notice, this was all I had. This shows the importance of 3D printer or 3D print orientation. These parts were printed vertically, and you can see how the circles came out very round. These parts were printed horizontally. The circles are not round. And also these layer lines going across, you can kind of see them there, make a bunch of flats as well as shear planes. So when I tried to assemble this and I put a bolt through, it almost immediately broke. 3D printing orientation is vital to get right if you want your part to be strong enough to be useful. Here's an example of a robot component printed with a bunch of different colored resins. If you get your settings dialed in and you get your post-processing down, you can make awesome looking prototypes with resin 3D printing. It'll save you a lot of time and potentially headaches. On the subject of 3D printing, we're working with plastics. Why are there so many plastics? Well, sometimes you need something slippery. For your slippery plastics, maybe something like the lining of an inside of a hood. Let me get this picture back up because I don't have pictures of this. For slippery plastics, you want to be using something like PTFE Teflon or HDPE or POM Delrin. Sometimes you want bendy plastics. Bendy plastics might be your nylons or TPUs. Sometimes you want sturdy plastics, your ultra high modulus weight HDPE, polycarbonate. It all depends on what component you're making, whether you're 3D printing or machining it, and how big the component is. Teflon.
On the subject of 3D printing,
yes.
What are some of the most commonly 3D printed parts on our robots?
On our robots, we make a lot of small components to hold like camera enclosures. I wish I had some good 3D printed pictures from our robot. I apologize for not providing those guys. Yeah, we made some camera enclosures. We 3D printed some small mechanisms. Spacers and pulleys are something that we like 3D printing because sometimes we want a very specific pulley Not always the size of the teeth, but also the offsets, what type of belt we're interconnecting with, stuff like that. Can you guys think of any examples of stuff we 3D printed?
Yeah, I would say spacers and pulleys are the examples that I can think of.
Spacers and pulleys are the big ones. Not always a fan of that, but yep.
Yeah, and then another question going back to what you were talking about earlier. What
Sure.
tool would you use to cut off the end of a sim if you wanted to use it with the versaplanetary gearbox?
The end of a sim, meaning the shaft? Or
I assume, yeah. I don't know what else it would be.
yeah, so I believe you're not allowed to modify motors. I don't know if you're allowed to modify their shafts. But in that case, you'd be cutting steel. And you're cutting steel on a rotating component like a motor. That's something you're going to want to do in the lathe if possible. Otherwise, steel cutting mechanisms are hacksaws, carbide in the mill, high-speed steel. Hacksaws tend to be made of high-speed steel. You are not going to want to use something like diagonal cutters or metal shears. You won't get through those components. There's also the option of an abrasive wheel, something like a Dremel or a cutoff wheel cutting bit.
That's all the questions we have for now.
Okay. Continuing on with plastics. This fancy looking word is the name of the plastic that makes up water bottles, polyethylene terephthalate. Polyethylene terephthalate is great for holding water. It is not so great for holding acetone, for example, or alcohol, isopropyl, or other solvents that would eat through this plastic slowly. It's very important to use the correct plastic for the correct job. And the final touch on plastics is definitely not food safe. Almost all 3D printed plastics that any of us would be using are not food safe. And when they're not food safe, it means that it's also not really safe to ingest it. Need to be careful when working around plastics. Need to wash your hands before eating dinner after you've been cutting stuff on the lathe all day. Some of these plastics that get into your system are cumulative and they can do some damage later on. So plastic does not always mean that it is safe for you to touch, handle, ingest, or so on.
Are there ways to make hybrid plastics that are, for example, both bendy and slippery?
Of course. One of the ways is encapsulating plastics. You would put a rigid plastic inside of a flexible plastic. Also, some 3D printers or other machines allow you to mix plastics on your own. You'll have your flexible PETG and your less flexible PLA, and you'll get a blended PLA PETG that's a little bit flexy, a little bit stiff. Most plastics that you'll be working with, you're just going to want to buy them in the type of flexible stiffness, slipperiness that you want. It's much better to just plan according to the material you have rather than try to kit bash materials together in order to get a new result. If we were really good at doing that, I mean, I would be 3D printing my own zip ties rather than buying them. Anything else?
Not right now.
All right. For this next one, when you're a hammer, everything looks like a nail. We're going to go over what is and is not a hammer. So, this is a hammer, right? This is a mallet, a type of hammer. This is not a hammer. In the same way that people use screwdrivers wrong, you wouldn't believe what people use as a hammer. Using the right tool for the right job is a recurring theme in this presentation. So don't use a wrench as a hammer. But on that note, This rubber mallet is not super good at hammering nails in or bending metal. And this will shatter a 3D print that you're trying to get wedged into place. You need to use the right hammer for the right job. There are plenty of them out there. The correct way to use a wrench, I have a slide coming up that demonstrates. I've also left my wrench across the room. So we're gonna stand by my picture that I'll show you in a moment. But wrenches are actually directional. Believe it or not, the thick side is for applying torque and the thin side is for securing your part. If you use the wrench like this and you're applying torque to the thin side, you're basically weakening the ability of your tool. Now, I get that you can't always fit the wrench in because wrenches aren't straight, and sometimes you have to flip it upside down to reach it. But when applying the main majority of the torque, you don't want to use the wrench in the wrong orientation. Use it correctly. Vice
Going
grips
back to
aren't wrenches.
plastics,
Yes.
what plastics would you recommend for teams that don't have the capacity to machine aluminum but can cut other materials like plastic on a router?
Oh, excellent. So the plastic that's used most heavily is polycarbonate. There's a lot of brand names out there like Lexan. Polycarbonate is very strong, and strong is kind of a catch-all word to use, but polycarbonate is good at not breaking. It is a little bit flexible though, so you need to keep that in mind. If you remember 971's 2019 intake mechanism, the sides of it were made of polycarb and it would flap around as we drove, but it also never broke. So that stuff's great. Other materials that are fantastic for using if you can't really use aluminum, you have your engineering materials like your nylons and your Delrins. Both of those are great for making components. They each have their own time and place. Nylon tends to be a little bit stronger than Delrin. Delrin is self-lubricating a little bit. So Delrin is good for if you have components that need to slide against each other. A lot of gears that you buy out there are made of either nylon or Delrin. You'll see wheels that are made of polycarbonate. So if I had to suggest components or plastics to use other than aluminum, I would go with polycarbonate, Delrin, and nylon. Those ones will take you pretty far.
Someone's asking, oh, I think this might be a joke. Why is that calling an adjustable nut rounder a wrench?
Can you say that again?
Why is that calling an adjustable nut rounder a wrench?
Yes. In the same realm that vice grips aren't wrenches, this is also a type of wrench, but it is not. I wish I brought more tools over so I could show you guys. There are the right tool for the right job. And these adjustable wrenches, while great for some things, are only really situationally the preferred tool. Not a wrench. Thank you for pointing that out. This is not a wrench.
And then another question someone is asking, what filament-based materials do you recommend printing with besides onyx?
So onyx is great. Onyx is expensive. Onyx is a blend of carbon fiber and nylon. If you're capable of printing in onyx, you're capable of printing in nylon. I would recommend nylon. Alternatives to nylon are polycarbonate, which is very tricky to print with. And there are some lower market filaments. PLA is stiff and highly accurate, so it's good for making sure things fit. PETG is a little bit flexible and pretty resistant to shock. ABS and ASA can survive high temperatures. I don't think FRC robots, experience high temperatures very often, but there have been fires in the past. So if you need something to survive high temperatures, polycarbonate, ASA are your go-tos.
What are your thoughts on PVC, specifically for cutting on a CNC?
PVC, polyvinyl chloride, has its time and its place. I mean, PVC is kind of a weaker material, and although it's widely available and can be machined quite easily, I would say it is less preferred than using something that's a little bit stronger, like a nylon.
Thank you. That's all we have for right now.
Good, good, good. Yep. Sorry about the interruptions, guys, but I prefer to just get shouted at and answer the questions as they come. So vice grips aren't wrenches. In the same land where this is not a wrench, vice grips are not wrenches. Vice grips have a little gap in the middle, which we'll show in a picture in a moment, that is great for rounding off hex head bolts. Please don't use vice grips when you could be using a wrench. We'll talk about torque wrenches. I brought my little torque wrench here, and I'm going to demonstrate the right way to use it and read it. There's a time and a place for torque wrenches. Generally, you won't be using them on the robot unless someone really has a specific need for a specific torque. Sometimes that comes when you use an off-the-shelf component and it gives you a torque spec. So rather than just kind of crank it down until it feels good, I'll show you how to use the torque wrench. And the last is a method that I call 1-1-2 repeat. It's a good way to use a hammer without hitting your thumb. Oh, all my pictures are gone. Fantastic. Sorry about that, everyone. Torque wrench. Torque wrenches are sensitive to shock. If you drop a torque wrench, it might lose its calibration. Oh, this is going to be real difficult to see. Sorry about that, everyone. So there's a small scale that can be read, as well as a dial that you turn, and this is going to be miserable, I apologize. But the way that these dial-in torque wrenches work is you crank this down until you reach your desired torque spec, secure it in place, and then use as a normal wrench. A torque wrench, just like vice grips, is not a normal wrench. Please don't use a torque wrench as a ratchet or a wrench. If you drop it and it loses its calibration, you should not be using it anymore if possible. Same way you shouldn't drop calipers and keep using them. These are precision calibrated tools, and if you need an accurate number by any means, dropping your tool is the #1 way to make sure that you never get that number right again. Since my video is missing, I'm going to have to demonstrate on my hand, I guess, my 1-1-2 repeat mechanism. So when you see people using a hammer.
Off your presentation though,
Oh,
so
yeah.
your pictures video, your
There we
bigger,
go.
yeah.
Oh, I know what I'm doing. All right, can you see me now?
Yes, thank you.
Sorry about that, everyone. I'll show you the torque wrench again real quick because my bad. Apologize. I actually took some nice pictures, I promise. There's the scale I was talking about. That's what you use to determine what the torque setting of your torque wrench is. Everyone has walked into a shop and seen someone wildly flailing a hammer around. And unfortunately for many of us, a lot of us have had to hold a component in place while someone is wildly flailing the hammer around. So the best trick that I've found for the rookie to make sure that they don't errantly hit someone's hand is to do what I call the 1-1-2. Here's what that looks like if you're the head of a hammer. 1, 1, and then you swing it in. The way that that'll look is if I'm just hammering on my hand, for example, be tap, tap, hard hit, tap, tap, hard hit, tap, tap, hard hit. It helps you line your shot up. It helps you get calibrated as to what you're doing. And then when you finally swing in, you're way less likely to miss. I've broken my thumb 3 times while hammering stuff, so it's highly effective. All right, let me share my screen real quick. Come on. Bonus, the vernier scale is also magic. Just like 3D printing, everyone out there has been exposed to the magic of a set of good calipers. Oh, I gotta stop doing this already. Okay. A good pair of calipers. Lost all my pictures, guys. I apologize for that. Good pair of calipers. This is not. This is a cheap pair of calipers. But it's very important that you zero your calipers correctly. So if you can see that, it says 0. I just turned it on. The best way to zero your calipers is when you turn it on, using the mechanism for tightening and loosening them. Just give it 1, 2, 3 clicks down, then hit 0. Now you're certain that it's zeroed, because if you just kind of turn your calipers on, hit 0 and go, it may not be actually 0. And then you'll be off by as far off as your calipers were squeezed together or pulled apart. So it's very important on your calipers that you get proper 0. Despite what you see on the internet, calipers are not a good, they're not a good scribe. You should not be using them for scraping paint off of metal or for marking surfaces. It's like the #1 way to ruin the ID and the OD parts of these things is to just scrape it along a piece of metal and ruin that nice finish. And similar to the torque wrench, if you drop your calipers, they may never read accurately again. As you can see with these, right now we're 0. And now we're, where'd it go? Yeah, 853. That's not correct. I've dropped these calipers many times. They no longer read accurately at the big numbers. And now that I've swiped it back to 0, we're displaying 580-ish. So it's very important to take care of your measurement tools. And if you ruin them once, they're basically ruined forever. Calipers can be very expensive, and you don't want to be the person that keeps dropping the expensive tool that you guys rely on.
Someone asked what your favorite torque wrench is.
Snap-on. We used Snap-on torque wrenches in the Army, and we had a torque wrench that someone broke the head on one day while torquing parts of the helicopter. The Snap-on guy showed up, and he took a component off of what was a torque wrench from 1954 and swapped on a new one, and it fit and worked perfectly. And you pay a lot for the name, but you also pay a lot for that lifetime warranty. I'm not kidding. This wrench was from the 1950s, and we got a replacement head, and it was working good as new. So if it were up to me, I would have Snap-on tools. However, I don't know how much you guys make, but Snap-on tools are expensive, so I buy Tecton or Harbor Freight brand.
Someone else asked, what experiences do you have using wood on your robots?
We use wood for prototyping a lot. 971 built a wood router, or built a router, I should say, a CNC router. And wood is a great prototyping material. I don't think much wood has made it to the final robot. Wood is kind of less effective in every way than Lexan or aluminum. So wood is great for prototyping. It's cheap, it's fast, but I don't think we use it in the final robot.
Another question, are the Klein models good?
Yeah, Klein makes good tools. Klein, when Yeah, they're all pretty good. In fact, what's it called? I think when is the same. Any other questions?
That's all I have at the moment.
All right, guys. Sorry about the pictures. Sorry about rambling so much. And also sorry for the technical difficulties. I am available if you have any further questions, but I believe we need to wrap this up. So thank you for tuning into my TED Talk, and good luck building robots.
Sounds good. Thank you, Zach.
Bye, everyone.